Today I'm going to speak about a sort of exotic topic. I think it's exotic because I'm going to talk about extended warranty for cars, which I guess is not a usual topic mentioned in the Earnix conferences. And exotic as well because I'm going to talk about the batteries of electric vehicles. And it's an emerging risk. And so I wanted to share with you the challenges we're facing on this topic. So I'm working for Stellantis Insurance. Stellantis is one of the largest car manufacturers in the world. As the name is not very well known, so I prefer to show here the main brands of the group. So it's a group whose largest market is the US, and with brands like Dodge, Ram, Jeep, of course. Our second market is Brazil. And then only France and Italy, so our third and fourth markets. And we are very heavy also in Germany and in the UK with the historical brands of Opel and Vauxhall. So Stellantis Insurance is a subsidiary of the group. We are selling insurance products linked to the financing of the cars, but also warranty and auto insurance. I've put here some figures, so we are not a major player yet, but I can tell you that insurance is one of the most important strategic pillars of the Stellantis group. First, because it's an additional source of revenues, but also, perhaps more importantly, it's a way for the OEM, for the car manufacturer, to increase the loyalty of its customers to the repair network. So now I'm going to talk about electric vehicles. I guess most of you are aware of the regulation on electric cars. You know that the EU is targeting to reduce its CO2 emission by 55% by 2030 versus 1990. And you know that the auto industry is a very large contributor to those CO2 emissions. And so there's a regulation which has been passed in 2021, which requires the OEMs in Europe, say, for each new car sold, to reduce the CO2 emission of those cars. And so those emissions have to be reduced by 15% in 2025 versus what was done in 2021. By 55% by 2030, and the target is that in Europe in 2035 there is minus 100% CO2 emission of the car, so that means we don't sell anymore what we call ICE cars, so internal combustion engines vehicle, and just sell electric cars. So you can imagine it's a huge constraint on the European OEMs because the regulation says that for cars which are sold, sell cars above this threshold of CO2 emission, then we have the penalty. And the penalties are heavy because some mention penalties for the European industry of 10 billion euros, some others 16 billion euros. And so it's a massive challenge for the OEMs to, within such a small time frame, to deliver that. We were talking about time to market for the insurance industry, but here we are talking about core industry. So we have to change the manufacturing of the car, the plants, and as you can guess, it doesn't happen in a minute. There's the motor show in Munich at the moment, so you heard some of the people talking from the industry. So Antonio Filosa, the CEO of Stellantis, spoke 3 days ago. A lot of us in the industry think that we are just shooting in our own foot, and we are paving the way for the Chinese OEMs to invade our market. So I'm not going to talk about that today, but this is a huge challenge for us. And the way we're going to manage it is not by reducing the emissions of our existing engines. One of the ways is to increase the share of the sales of electric cars. And that's a chart which has been produced by the European Commission, where you see progressively we target to reach this 100% share of the sales by 2035. Today we are around 20%. It's a bit plateauing at the moment. It's very difficult because a lot of states have reduced the subsidies to buy electric cars. So it's another challenge for the OEMs. And us as Stellantis, so we have invested, I think the figure is public, we have invested 15 billion euros over the last 5 years to transform the plant, transform all the manufacturing process. We are progressively, we've delivered 75 new models. So we're pushing also for the increase of the electric vehicles volumes. At the moment, so it's good to have an offer of electric cars, but it's another story of having people buying those cars. So here I've mentioned a study done by McKinsey last year about what are the main issues, concerns of the consumers to buy electric cars. So the first one, of course, is the price. The second, this one is going to fade away because we can see the price of manufacturing of the batteries going down. And plus with the gentle pressure of our Chinese colleagues is going to help. So this one is going to disappear progressively, for sure. The second one is the insufficient driving range. And again, this one is probably going to go down as well because now most of the new models sold in the market are showing a range of above 500 kilometers, some up to 800 kilometers. So the technology will help us to lift this concern. The third one, I think, is the one which, in my opinion, is going to be the most important one, is the lifetime of the batteries. So what's happening? For the batteries in the cars, it's just like the batteries in your mobile phone. You know, the capacity is going down of your battery on mobile phone. For cars, in the same. And the concern is that people buy a car, and if it's a car above 3-4 years, people can be afraid that the battery is going down, and then they will have to replace the battery. And you know that a battery of an electric car is still something expensive. So they think that the car is going to be worth nothing because changing the battery is equivalent to changing the car. And that's what you see on the residual value of electric vehicles in the market. So here's an example in the French market of a largely sold model. So you have what we call the residual value. So it's 100% is the value of the car when it is sold, new car. And then you know that the value of car is going down with the age of the car. And what you see, a blue curve corresponds to the ICE, so the petrol version of this car. And the green one is the same car, but for the electric version of the car. And you can see the discrepancy is significant. And that's the problem. That's a problem for all the people who are financing cars in the finance industry, because you know that a lot of cars are sold to leasing companies. And leasing company, they charge a monthly installment. And the monthly installment depends on the residual value once the car has finished its leasing, because OEMs or financial company buy back those cars to the leasing companies. And if the residual value goes down, that means that the monthly installment for leasers, for electric cars, is going up. So this is an adverse disadvantage, competitive disadvantage for electric cars versus ICE cars. And there's also a financial issue at stake. So basically, I'm sorry for this long introduction, but I'm going to explain now what we are working on. So the OEMs, they give an OEM warranty. At Stellantis, for electric cars, we give an 8-year warranty on the batteries. So up to 8 years and up to 150K kilometers. What we've been asked by our colleagues from the used cars and from the marketing is to design an extended warranty to cover the battery beyond the 8 years, so that we reassure the consumers that, okay, they buy a 4 or 5-year-old electric car, the car will still be usable beyond those 8 years. So it's a bit of a, what's okay. So what with this topic? So it's a bit specific for two things. First, we don't have many history on electric vehicles, and the volumes have started to develop only 4 or 5 years ago, and now we have to extrapolate what's going to happen after 8 years, up to 12 to 15 years. So it's an actuarial challenge to project figures beyond those dates. And the second one is we have a lot of new components in those cars versus what you used to know in ICE cars. And the last one, which is new, is the risk linked to the loss of the capacity of the battery. And that's what I'm going to talk in the next slide. So here quickly, I'm not going to talk long about it, but electric cars, the electric engines, it's a new system. So that means new parts. You have, of course, the battery. You have an engine, electric engine, but also you have a lot of new components. The inverter is what transforms the direct current produced by the battery into alternative current for the engine. You have a power controller which controls all the transmission of energy between the battery, the car, and retroactively to the battery, because in most of the electric engines you have a regenerative braking system. So you know if you recharge the battery if you stop accelerating. And you have also all the complexity linked to hybrid cars with the onboard charging between the electric engine and the thermic engine. So new components, and within the battery, there are also a lot of things. You have, of course, the batteries are made of cells, as you know, but you have also what we call a BMS, a battery management system. So that's the sort of the brain of the battery. So that coordinates all the level of voltage in its cell, allocates, make sure that the energy is spread out properly across the cells, and also manages the temperature of the cells, because those batteries, as you know, they heat up. And that's why we need a cooling system as well, so that to avoid a fire or propagation of fire from one cell to another. So all those, you have fuse in a battery as well. So a lot of things which need to be, the breakdown of those elements have to be anticipated, and we don't have much history on that. So that's the first challenge. Now I'm talking about the battery, so the battery capacity. So the battery capacity is measured by a KPI called the SOH, the state of health. And the state of health, it goes down with the battery, whether you use the car or not. So here you have a plot of a sample of electric vehicles, and it's plotting the SOH and the evolution over time. In the horizontal axis, what we plot here is what we call the WACO. So the WACO is an indicator which gives the maximum between two ratios: the ratio of the age of the car divided by 8 years, and the ratio of the mileage of the car divided by 150K. So when the WACO reaches 100%, that means that the warranty of the manufacturer has ended up, and we are taking over. And so what you see here is that you have plots. The gray plots show cars where the WACO is driven by the mileage of the car, and the yellow plots are the one where the WACO is determined by the age of the car. What you see is most cars, we don't have values above 50, for many cars, not above 60% because only 5 years of experience. And what you see is progressively, the SOH is going down. And in the industry, what we commit, we know that if the SOH goes below 60%, the battery becomes dangerous because of the risk of shortcut. And so below 60%, we have to replace the battery. And so this risk would be covered by the extended warranty. So we have to assess what would be the distribution of SOH with the age of the car. And that's the actuarial part I wanted to talk about today. So what we did, we have an important database where we have weekly measurements for 55,000 cars, where we can see the evolution of the SOH week after week for those cars, and depending on a certain number of factors, so how much the car is driven, of course. We have also the type of battery, where the car is driven, and we have also information on the pattern of the charges. The fast charges, slow charges, how many charges, how the car is used, and that's what we're using in a model based on, and we leverage the very lovely software of Earnix to derive a model to extrapolate the evolution of the SOH. And here I'm going to share some outputs with you today. It's quite interesting. So here you can see what we've modeled is what is the annual deterioration of the SOH. How do we project that? And what impacts the SOH is, you can see, of course, is the mileage. And the more you use the car, the faster the capacity of the battery is going down. There's also the age of the battery. So what we see is at the beginning, there's quite a short drop in the SOH, and then it goes down slowly between up to 3 years, steadily. And then after 4 years, it seems to slow down, but we don't know what's going to happen. Is the SOH going to keep like that and quite a slow curve, or is it going to drop again? So that's the assumption we've made in the design of the product, and the estimation of the risk is to have a stable SOH deterioration on an annual basis after year 4. And what you see interesting as well is if you use more fast charges, it tends to accelerate the deterioration of the battery, but to a lower extent to what you see in impact on the mileage. So if some of you are driving electric cars, so be careful with not charging too often, not to use too often the fast charge facility. And what is interesting as well, sorry, I can't see the map. Okay, so here, sorry for that. There's a map of Europe, because we're working for this product in Europe. And what you can see is the SOH deterioration is much faster in the southern Europe countries. Why? Because the optimal temperature of the usage of a battery is about 25 degrees Celsius. And you know that with the global warming, the temperature getting high in Latin America, in southern Europe. And so that we can clearly see that the SOH going down in southern Europe, much faster than in the north of the country. So that means that in the pricing of this product will be different across the territories in Europe. And here you have a sort of, these are the projection of the SOH. So in the bar show the exposure, how many cars, electric cars we have in the years. That's the years in an horizontal axis. So we have a good reliability history up to 4 years, and then we have done the projection. And here you have the average in the blue curve, and you have the 10 percentiles and the 19th percentile on the red and the green curve. So basically, it gives us the distribution of the SOH. And based on that, we can derive we can estimate the proportion of cars which will go below a SOH threshold. So 70%, 65%. And what you can see is according to the age of the car, and the risk of, that's what you see on the curve, you can see the risk, the frequency of the risk is expected to increase very much after 8 years. Linked to, and depends, of course, on the threshold we are taking to trigger the replacement of the battery. Voilà. So that's I wanted to I had to remove all the scale on the vertical axis for confidentiality reasons. But just wanted to share with you because I think it's quite interesting. More and more of us are using electric cars. As a consumer, I think it's interesting. For us, actually, it's a real challenge because in terms of academic modeling, we are all used in the PNC industry to use GLMs. Here, it's, we need to use a lifetime modeling, and it's not so common. So that's, I would say, a challenge for us. The other challenge is that we don't have the history. So that's very difficult. Regulation is changing, so this impact as well, because the technology and the type of batteries, you know, we used to use in the past the lithium-ion batteries. Now it's moving to, I don't know how to say that in English, phosphate. So I don't know what's the, but it's another technology. The frequency of the breakdowns of the batteries are completely different. So that's, we have to imagine what's going to happen with those new technology. And what's interesting for us actuaries and two colleagues in the team here is that we have interaction with engineers. So for us actuaries working in, I would say, in a conceptual world, it's very nice to interact on a day-to-day basis with engineers, where we are talking about not concrete, but tangible assets. Voilà. So for us, very interesting. And then I think for the consumers, this can have a very interesting output, is to give advice to the drivers on how to save and use in a better way the battery to avoid the risk of collapse of the battery due to the reduction of the SOH.